Hello and welcome to this CPD video from metacognition.org.uk on graphic organisers. Now, this video is different from the main video. This is looking at graphic organisers to use in maths. So the reason for this separate video, 2 points really. Firstly, I'm a maths teacher, and secondly, because graphic organisers are a little bit more difficult to use in maths. So that is why there's a specific video on it to support the scaffold and the use of graphic organisers in maths, because there's still a huge advantage to using them, but finding out and embedding them within practice can sometimes be a little bit more difficult. So graphic organisers, they're part of the planning stage of metacognition. So we don't have our metacognition video up yet on the website, but the planning stage is the initial stage. It makes quite a lot of sense. Before you complete any task, before you complete any sort of problem solving, exam question, you need to do some level of planning. You need to do some level of understanding what the question is about or what information you're given. So this is where the graphic organizer comes in, because they give you the information, the planning information you need to go ahead and complete a task or do some problem solving. So firstly, when we're going to be using them. So I'm going to go over two different types, and they're both going to have their own little advantages, but generally these are when they can be used. So firstly, they're fantastic recall and revision activities. So if you know that you've completed a topic or you've completed an activity, you can then give students one of these graphic organisers and get them to write down everything they know. So getting students to write down everything they know from a memory sort of name is sort of a knowledge dump, a memory dump, where they are writing down everything that they can recall. Obviously, there are lots of things that you can do with that after that. You can get students to compare, you can get students to put it all together as one big class graphic organizer and really see where weaknesses are in recall or where strengths possibly are in recall. It's great low stakes testing, so you can make this recall a bit of an assessment. So you can score it, you could take it in and provide feedback on it. So you can turn it into a bit of low stakes test, low pressure, not trying to sort of scare your students, but seeing, right, here's your knowledge graphic organizer, fill it in as best you can, and then I'm going to assess it, or you're going to assess it to see where your weaknesses are. It's fantastic for a little bit of evaluation and support students in identifying what they need to revise in the future. It's great for problem solving. So if you're needing students to identify key information from a task, or if you're wanting them to identify key information that they're going to need to tackle a problem solving question, it gives them a scaffold they need. So for example, they could record all of the information down given in a question and use this to help support their answer. As mentioned, it helps them consider the requirements of a task, so they can get down the key information from a question, or they can use the question to put down all of the information they know on those certain topics. So again, it's supporting them in evaluating their knowledge and skills before they answer that problem. And then obviously the overall aim of this is supporting with the planning. So like we said, metacognition stage 1, the first stage is planning. Students need to be very, very good planners. They need to be confident in the strategies that they've got, because otherwise they're going to get to year 11 and they're not going to know how to answer those problem solving questions. There are so many in the exams now, there's so much on the curriculum. Students need to have these strategies so that they can tackle these exam questions. The better they are at using things like graphic organisers, the better they're going to do in the exams. Right then, I've told you what they're good for. I'm going to try to tell you now why you should be using them, try to convince you of this. So firstly, it supports that higher order thinking. So it can take a student who maybe is a grade 3 or 4 and push them up to a strong 4 or grade 5. It allows students to tackle problem solving tasks that they might not have been able to do before, or it supports students' revision so that they're able to do more than they could before. So many students have poor revision strategies, but by using the two graphic organisers I'm going to show you, it can support the strategies they've got through revision and support their higher attainment. Secondly, we never do anything because it looks pretty, but it's always a bonus if it does. Well, if graphic organisers massively support students' thinking and deeper thinking, it's a massive bonus then that they look really pretty. Students like filling them in. They look really nice. So if you've got students on board with them, if students like filling them in, it's going to make them think more. It's going to make them complete the documents more. It's also great for linking together knowledge. So though we as teachers might understand the benefit or see how algebra and geometry links together, for example, students often don't. However, a graphic organizer can help to support students in identifying the links between topics and understanding where different things link together. Not only is that really, really valuable for, say, problem solving where different topics are put together, it's actually really beneficial to students' motivation. If they can understand where things link together and where all their learning comes from, it can really give them a boost and understand, oh yeah, this makes sense. I get why we've done this now. Next, it's fantastic at supporting sticky knowledge. Obviously, from the memory point of view, we've got our short-term memory. It's the facts and the information we're dealing with at the forefront of our mind right now, and we're trying to encode that. We're trying to move that to our long-term memory so that it is information that we remember, information that we can recall in the future and apply to future problem solving. Graphic organisers help us to take that information from our working memory and cement it into our long-term memory. And also it helps us keep it there and keep it fresh by doing the retrieval questions. So if we're trying to retrieve the information from our long-term memory, say fill out a graphic organiser, it really helps to strengthen the knowledge and recall that we've got. It really is positive at supporting cognitive overload or stopping cognitive overload. So obviously this idea here is you don't want students to be dealing with too many facts in their working memory, otherwise they're just not going to be able to complete the task as well. So by reducing the amount of load, by breaking it up and putting it onto a graphic organiser, you're reducing the load that students are going to face, and therefore they're going to find completing tasks a little bit easier. As mentioned, it's part of that planning stage. Students are particularly poor at planning in mathematics because we don't do very much of it. We don't typically sit down and plan things. We don't plan essays. We don't plan descriptive writing. We just kind of jump in often. Students need to be able to plan. They need to be able to do those 4, 5, 6 mark questions. And for that, they need to be able to understand what they need to do. That's where the planning comes in. And then lastly, a bit of dual coding. Students can associate different parts of graphic organisers with the different bits of thinking, and it supports them in recalling the information and applying it then in problem solving or in exam questions. Right then, so there's a few things that we need to consider before we use these graphic organisers. Firstly, we need to understand the knowledge students have and what we can expect them to recall. So if students have only just been taught the information, it's probably unreasonable to expect them to recall it all independently onto a graphic organiser. So it's that professional judgment of how much do they know, or how much have I taught them, how much have they remembered, which unfortunately is probably going to be less, and therefore how much can I reasonably consider them to recall. If I'm expecting them to recall more than is reasonable, it's going to lead to anxiety, it's going to lead to students being stressed, and it's going to lead to them not seeing graphic organisers as low stakes testing, but actually seeing them as high stakes testing and just really stressing them out. You also need to consider what key information you want students to be engaging with. So what do you want them to be doing with it afterwards? Are they doing high order thinking? Are they doing exam questions? Are they writing up a task? Are they writing up a process? What do you want them to do with it afterwards? So you need to be really clear on that so that you know what you're doing with that graphic organizer afterwards. So it's not always just an exam question. You might want them to write up a problem. You might want them to write up their own questions, whatever it might be. Be clear on what you want them to do. Now, graphic organisers provide notes and ideas. It's not teaching, it's a planning tool. It's a scaffold. It takes away the need for us to produce a scaffold, and it also supports students' development because they're the ones producing the scaffold. But it's not the end point. It's a support to get you to the end point. Now, here's the last important point in terms of cognitive load. I've mentioned that they help reduce cognitive load. Done incorrectly, though, they will tip students over the edge with cognitive load. So these are two important rules. You cannot give students a new graphic organizer that they've never used before and new content. It's too much to deal with. So if you're giving them a new graphic organizer, one that they've not learnt before, then you need to give it to them with information that is automatic. If you want to give them a graphic organizer with new information, it has to be a graphic organizer they've used before. One of the two things needs to be automatic and coming from a long-term memory point of view. So new graphic organizer, fine, but information they already know. So maybe stuff they've revised for the last 5 years in year 11. If it's new information, possibly year 7, give them a graphic organizer they've used before. Right then, as I say, there are two main types, so I'm going to whiz through them now. The first one is the circle map. You can see here, you've got your main idea or concept in the center circle, and you've got ideas, examples, and definitions around the outside. So it's pretty straightforward. It's used for defining within a context. It's basically or here, as we say, a knowledge dump is basically putting down everything that you associate with an idea. So if you put down shapes, you might put down a definition, examples, draw some pictures out, maybe put some non-examples in, that sort of thing. So it's a tool that you can then use for other things. So you can get students to orally explain their wheels. So you could do a little bit of pair and share. You could get them to explain it to a group. Oh, this is what I've put down. What did you put down? Maybe they can add a little bit more information in as well. Like I've said here, you can get students to add in from each other so they can go around the class, identify what they've missed out, identify what others have missed out, really evaluate their work and see what they need to be adding in. Now, obviously here you need to be cautious that you don't get 5 or 6 students doing it completely and the other 24, 25 knowing that 5 minutes later they're just going to have the opportunity to copy. So you're going to need to build in some sort of responsibility there to make sure that students aren't just doing nothing. It's also a great revision tool for students. So if you've just finished a topic, you can say, right, put fractions in the middle and write down everything you know, or put down adding fractions and everything you know, put down the definition, put down the format, the process, etc. They can do it in class. They can do it as homework. It's also fantastic for a pre-teaching assessment. If you've got a class and you don't know how much work they've done on a topic, you don't know how far they've come, give them a circle map, tell them to do a knowledge dump, tell them to write down everything they know, take it in, assess it, and then you can build off that. And then you can also include a frame of reference. So that is this square box around the outside. And simply outside the circle, students then have to write down how they know that information. So have they got it from a textbook? Did they learn it at primary school? Did they get it from the internet? Did they get it from Hecate Maths, My Maths, whatever it might be? How do they know that information? How do they know that they are correct? What is their justification for that? So we can see here we've got some examples. So you can see how it's used. It's quite nice for equivalent fractions. You can see how we've got the other equivalent fractions there. Different ways to make 10, all of these different bonds and multiplications, different types, multiplications, divisions, additions, timesing, add, etc. And then here, a bit of a definition of what an expression is, some key words there to support students' understanding of that. Right then, the next model is the Frayer model. So this is one I really, really like. It's a fantastic tool for revision at the end of a topic as well. Looks like this example here on the right. Definition, characteristics of a diagram is often quite useful, examples and non-examples. It is simply an opportunity to evaluate a topic. So you can give students this, you put your keyword or topic in the middle and tell them, right, write down a definition, give me a diagram, give me some examples, give me some non-examples. But you can take that further. It can be used as a recall revision task, so maybe just before an assessment or as homework, get students to produce Frayer models on the topics you're going to be assessing them on as a revision tool. You can also test for non-examples and identify misconceptions. So often, students put down misconceptions in the examples box. You can use this as an assessment. It's very easy just to skim over 30 Frayer models just to look at the examples that have been given. Are students putting misconceptions into that examples box? Or, for higher level thinking, have they identified misconceptions and have they put them into the non-examples box? So this is a really key point. Maybe challenge students to identify things they think students will get wrong and put them in the non-examples box. It's so easy. If, for example, you were doing a Frayer model on multiplication, students might put non-examples down as like an addition or a division. Well, yes, they're non-examples, but could they identify misconceptions with multiplication? So, for example, with decimals or with place value of the new answer. So it's really important that students can begin to identify what these misconceptions might look like. So from this, you can get students to compare their models, so you can get them to add in information, you can get them to produce a class Frayer diagram, or how I've done in the past, get them all with a different topic and pass them around groups every 6 or 7 minutes, and each get them to fill in and add on details. So each time it moves around the class, it gets a little bit more difficult. It's really pushing students to think more deeply and to think more deeply about those examples and non-examples. So a bit of a shout out to frayermodel.co.uk, which has an amazing array of different examples of Frayer models in mathematics. So I've put up a few examples on the slides here just for you to look through, so you might want to pause and just have a look at them, but it really shows you what can be put into these and what can be produced. 2 more examples here. Right then, that was just a whistle-stop tour. Those are the two main graphic organisers for mathematics. Those are the two you're going to be using most often. I wouldn't worry too much about the other ones because they're normally less relevant, or you're going to use them so little, it's just not going to be worth training the students up to use them. If you do want more information on graphic organisers, go and check out the main graphic organizer CPD video, but also do be aware that there will be student training on these videos on the website very shortly, and there are also going to be templates for those two models on the website. They're already up there for you. Thank you for listening. Bye.